Hi all, welcome to Geeks for Geeks. I am Utkarsh Kisarwani, your DSM mentor, and going to solve today's problem of the day. So the name of the problem is Equalize the Towers. You are given an array heights representing the height of towers and another array cost where each element represents the cost of modifying the height of the respective tower. The goal is to make all towers of same height by either adding or removing blocks from each tower, modifying the height of the tower, add or remove I by 1 unit cost of I. Return the minimum cost to equalize the heights of all tower. The question is saying that they will give you two array. First one is height. The heights are 1, 2, 3. 1, 2, 3. And next we have a cost. So cost is 10, 100 and 1000. Correct? So the question is saying that you have to make all the heights equal. And if you are increasing the height by 1 unit, so it will take you this much amount of cost. And you have to tell the minimum cost by making a minimum cost for making all the towers equal. So let's suppose I want that height of all the towers will be equal to 1. So here it is already 1, so no need to change this height. Here we have to decrease 1. So for decreasing 1, how much it will cost? 100. Then here we have to decrease this height by 2, so means plus 2000. So it will be equal to 2100. Or what we can do? We can also make all the height equal to 2. So if I am making all the height equal to 2, then here I have to increase this by 1. So it will be 20 for this tower. Here the height is same, so 0 for this. And here if I want to make it as 2, so it will be decreased by 1, so means 1000. So it is 1020. If I am making all the height equal to 3, then we need to maximize this by 2. So 20 for this. Here in this case, when the height was equal to 2, okay, so it will be equal to 10 here. Here 20 for this. This we need to add one height here, so plus 100. So it's costing 220. So the minimum is 220. That's sorry, 120. So that is what our answer is. So we have to do it. So what we can do for this? We will run a for loop and try to make all the tower equal to of height 1. So means like this. We will go at each index. So for int I is equal to 0, I should be less than n, I plus plus. And now I will again run a loop in this again and make all the height j is equal to 0, j should be less than n, j plus plus. What I will do, I will create a temporary here as temp, and I will see the cost for making all the towers equal to this height of I. So temp plus is equal to height of I, the current tower height, minus height of j. We have to take the absolute of this, because let's suppose I am at this, I is my at this position and j is here. So how much cost we need here? Absolute of this. So take absolute here and then multiply it by cost of I, not cost of j, because that will be the cost for changing the height by 1 unit. And here I will write that my answer is equal to minimum of answer comma temp. So like this we will do, but here the time complexity is O of n square. So we can further optimize this solution. How we can optimize? See here. We are always sure that the minimum height can be this 1 or the maximum height can be this 3. Means we need to make all the towers of equal size now. So what are the possible tower size we should take? So minimum 1 to maximum 1 and all the values between it can be we have to check for each of this height by making the tower height equal to minimum, minimum plus 1 like this to maximum, and see whichever cost is minimum. Okay, so what we can do also, when I will start from this min value, means I am taking this as the height of the all tower and calculating, so there will be a cost involved in it. When I will go towards the right, so it may be possible that at a certain time the cost will be reduced, and again if I will try to increase my height, the cost will again increase. So it means there should be a point where the cost is minimum, and this V type shape will be made. So what I will do, I will create this as low, this as high, and do binary search. Means we will take the mid value and find out the sum of the cost for making the height equal to this mid, and also check for this mid minus 1 and this mid plus 1. So if this mid value will be greater than this mid minus 1 and this mid plus 1, so in that case it means this is the answer. Not greater than, it should be less than, because this is our answer now. It may also be possible that mid lies here. So if mid will lie here, so we will move our start pointer to this side, and if our mid will lie here, we will move our mid end pointer to this side. Correct? So what I am saying, let's write code and then understand. So we will first find out the minimum and the maximum value. So int low is equal to int max, int high is equal to int min, int n is equal to heights dot size. For int I is equal to 0, I should be less than n, I plus plus, my L is equal to minimum of this L comma heights of I, and my maximum is equal to maximum of this height comma this heights of I. Correct? Now I will do the binary search. Okay, so while my low is less than equal to height, I will find out the mid value, mid height, that will be equal to low plus high minus low by 2. Then I will find out the cost. So cost 1 will be, let's call a solve function, where we will calculate the cost by choosing this height as the height of the all the towers. So we will pass here this heights array, the cost array, and the mid value. Similarly, we have to write 3 things here. Yeah, cost 1 will be for m minus 1, my cost 2 will be equal to for this m, and my cost 3 will be for this m plus 1. Now if my cost 2 is less than its left, means cost 1 and my cost 2 is less than cost 3, so it means we are at the bottom in this V-shaped graph. So in that case we will return cost 2. Else it may be possible that our mid value lies here. So how do we know that our mid values lies here? This is cost 1 this is cost 2, this is cost 3. So my cost 2 will be less than this cost 1 and greater than this cost 3. So if my cost 1 is greater than this cost 2 and my cost 2 is greater than this cost 3, so in that case I have to increase my starting pointer, so mid plus 1, else in other case I have to decrease my end pointer mid minus 1. In the last we will definitely get the answer here. So in the last written anything, what happened here, okay, okay, we also have to write this solve function. So int solve, we have vector of int and heights, vector of int and cost, and int mid. We will find out the sum, so sum is 0. I will iterate, so int n is equal to heights dot size for int I is equal to 0, I should be less than n I plus plus. Sum plus is equal to what? My height of I minus this mid. We have to take the absolute value for this and multiply this with cost of I. In the last we will return a sum. Take this in a single bracket. Okay, here it will be equal to high and here we have this as low. Your code output is 0. Okay, so what we need to do here now? Actually it is also possible that my graph will look like this now, that my these three values would be same, so that's why we have to put a equal to sign here also. So if the cost is minimum in the V-shaped graph, so we mean it means that we got the answer, else we were doing the same thing as I told you. For getting more clarity in this question now, you can dry run the approach, so you will get a better understanding for this question, because this is not a very basic question and you will have to dry run it once. If I will talk about the time complexity now, so it's a binary search. So binary search take log of n, and what we have this low and high means the h value is maximum of it, so log of maximum, and for this solve function we are running it O of n time. So the time complexity will be O of n into log of maximum of ARR of I. Okay, so thanks for watching the video. If you have any doubt, you can comment it below. Have a good day. Bye.